Hello and welcome to Geometry with Mr. Jameson. And the reason that we are here today is to learn about using inductive reasoning to make conjectures. So, if you guys recall, back in Unit 0, we looked at nodes and paths, and before we used to use inductive reasoning to figure out whether a network was traversable. So we would we can go from 1 to 4 to 7 to 2 to 8 to 5 to 1 all the way around. And that seemed to work pretty well, but it wasn't clear cut. We were never quite sure. So we came up with a general rule. And if you guys recall, our general rule was that if there are 2 or 0 odd nodes, then the network is traversable. So here, there's one odd node because there's 1, 2, 3 paths coming from it. And over here, at number 2, there's another odd node because there's 1, 2, 3 paths coming from it. The other nodes are all even. Here's 4, here's 2, 2, 2, 2. So this network is traversable because there are 2 odd nodes. And so that's our introduction to inductive reasoning. And now we're going to take a little bit of a closer look. So our lesson objectives is 3.1a and 3.1b. I can use inductive reasoning to identify patterns and make conjectures. And then I can disprove claims by finding a counterexample. The vocabulary terms that we're going to briefly discuss is inductive reasoning, using specific cases to prove that a rule or statement is true. So again, it's like looking at a pattern, looking at a specific case, and to prove that a rule is true. And we may not be able to totally prove that it's true, but while using inductive reasoning, we're using the best of our abilities to prove that it's true. A conjecture, a statement based on inductive reasoning that is believed to be true. Keyword on believed. We're not completely sure, but we are taking an educated guess. Basically, another way of thinking of conjecture is an educated guess. And then lastly, counterexample. It's an example that shows that a conjecture is not true. So again, it's an example. It has to be specific. So it's not that Martin is not taking an algebra class, it's that Martin is in geometry. That's from our pre-assessment. All right, so inductive reasoning, and remember our objective is to use inductive reasoning to identify patterns and make conjectures. So there's basically 3 things that are involved in inductive reasoning. 1 is identifying a pattern. 2 is making a conjecture or educated guess. And 3, prove the conjecture or find a counterexample. So basically trying to figure out whether the pattern that we've identified is true or not. So here, let's first work on identifying patterns. January, March, May. What's the pattern? Maybe it's every other month. So January, March, so January, February, March, April, May, June. So the next one, July. That's one way of doing it. But we could also potentially do, maybe it's months with the second letter is A. So January, March, May. There's no more. So maybe January again. We're not completely sure, but given our best guess, it seems like the pattern is every other month. Now let's take a look at part B. 7, 14, 21, 28. I'm seeing a pattern that is being added, or these are multiples of 7, or being added, adding 7 each time. So by going by this pattern, I can make a conjecture that the next item will be 35. So first, you need to identify a pattern, and then you need to make a conjecture. So complete each conjecture. The sum of 2 positive numbers is... Okay, so let's first come up with some examples. So some examples might be, okay, two positive numbers. So like 1, oops, can't see that. 1 plus 1 equals 2. Okay, great. Let's try something else. Let's just do like 12 plus 3 equals 15. And one more. 1,000 plus 5 equals 1,005. All right. So what is common amongst 2, 15, and 1,005? Oh, maybe they're all positive. The sum of two positive numbers is positive. Oh, who would have thought? Now let's take a look at B. So the area of a square, oops, let's not try to do two things at once. So the area of a square with side lengths greater than 4 is greater than or less than its perimeter. Okay, well, let's take a look. Let's look at some examples. So if we did a square with side lengths 5, the area is 5 times 5, which is 25. So area equals 25. And the perimeter would be 5 times 4, 1, 2, 3, 4. So that would be 20. So in this case, the area is greater than the perimeter. Let's do one more example. Let's do 7 and 7. So the area is, let's see if I do this. The area is equal to 49, 7 times 7. And the perimeter, P, is equal to 7 times 4, which is 28. So again, the area is greater than the perimeter. So we can make the conjecture that the area is going to be greater than its perimeter. The area of such a square is greater than its perimeter. Oops, okay. Now, let's look at another one. Let's try to make it a conjecture here. The height of 8 students in a class are recorded below. Make a conjecture based on the data. What conjecture can you guys make? Yeah, maybe that boys are taller than girls. Maybe that's one conjecture that you can make. So now that we have found patterns, made conjectures, let's look at finding a counterexample. Show that each conjecture is false by finding a counterexample. So for each integer n cubed is positive. So a counterexample would be finding an n cubed that is negative. How about if n equals negative 2? So if n equals negative 2, what is n cubed would be negative 2 cubed is equal to negative 2 cubed, which is negative 2 times negative 2, which is 4, and 4 times negative 2, which is negative 8. So that would be our counterexample. Here I did n equals negative 3 for another one. But all we need is one counterexample to prove a conjecture as false. Two complementary angles are not congruent. So an example would be 45 degrees and 45 degrees, but a counterexample would be anything. Oh, there's kidding. I messed that up. Two complementary angles are not congruent. So the counterexample would be 45 plus 45 equals 90, because the two 45-degree angles are complementary and congruent. So this was us disproving claims by finding counterexamples. So let's come back to our class of 8 students, 4 boys, 4 girls. Based on the data of students' heights, every boy is at least 3 inches taller than the tallest girl. What would a counterexample be? This boy would be a counterexample because he is not 3 inches taller than this girl. Are you serious? I wasn't